Hello again. So this is the second part of the videos on Elmer and Salome and the workflow for some Magneto dynamics 2D. Let's go straight to Salome to avoid the simple pleasures, eh? Right. This is Rupert, by the way. He's a cushion bear. Very, very rare kind of bear. Works with me in bear instruments. One of the many bears. So this is... sorry. Head of functional safety. No, I'm kidding. Look at him. He looks angry. It's more like to be some sort of accounting type. Right, this is the finished thing that we're gonna do. We're gonna do the geometry for this this C-core inductor effectively. So we're gonna end up with an air domain and the core with an air gap, and we're gonna end up with two coils in quotes. They're not actually going to be coils, they're just regions in which we will enforce a certain current density. So that's that. And we won't mesh it or anything in this video. If you want that, that's another video. It's just the construction part, which is in Salome, constructing 2D is pretty tedious, to be honest. Good. Just want to make sure the sound is on. You wouldn't believe how angry it makes me when I have to do the entire thing twice. So to do the 2D, you have to first use points, and having made up the points, you connect the points with the lines, and having connected the points with the lines, you then have to form them into faces, and having formed them into faces, you then have to join them, which is a bit confusing. If you don't join them all together, when you try to mesh it, you end up having to mesh several objects, and the consequence of doing that is that the meshes won't have... So if you had some nodes along this edge, there'd be a mesh for the air and a mesh for this region, and the nodes wouldn't actually be the same nodes on the edge, so the solver wouldn't know what to do with it. So you must be careful always to partition your problem. It took me a while to figure out that. So I'm going to let this go, and I'm going to start again from fresh. So we'll do new. The current visualization will be reset. No! Are you sure? Yes. That did less than I thought. Oh, there we go. Good. So this is actually what it looks like when you run the program. This is, I suppose I should say, this is Salome. If you haven't seen the first video in this series, then you won't know what it is, so maybe go back and have a look at that first. And you can also find out where to get it from, although if you just Google it, I'm sure, or your favourite search engine, I'm sure it will come up. So we can go here, and go geometry. And we have our geometry window will appear. Now, before you actually begin, you need to have a sketch. And under normal circumstances, I would just scratch this out with my claw paw on the ground in the dirt, and I'd put it on a piece of paper. But it's very difficult for me to show a piece of paper on the video. I have to hold it up, so we've got Visio instead. So this is bounding box dimensions. This is all in millimeters, by the way. It's very important that you set it. Otherwise you end up with a funny looking problem. Or a funny scaling problem. So we have our origin is 0, 0, and we have 50 millimeters in the, we call this X for the sake of argument, and 75 millimeters in the Y, and Z is into or out of the piece of paper that we're looking at. We can have negative as well. We don't have to go from 0 and just stay right a bit. And we have a bounding box that's not drawn, but this is the box that will contain the air, and it will also be the limit of the computation of the problem. So this is what we're going to draw out, and I'm probably going to have to come back to this screen quite a lot to check dimensions. It's going to be a little bit tiresome. So now might be a good time to put it on 2x speed, or as fast as YouTube lets you go. I'll sound like I'm on helium. So we'll start anyway. So first thing I'll do is go into the notebook. Oh no, it's all there. Oh, that saves a lot of effort. I thought it would get rid of those. When you click this, it will be blank. Some of them might actually not be right, but anyway, it will be blank, and you'll have to put something in there and then type a value. Fortunately, these are all here because I've already solved this problem, and I didn't realise that they wouldn't be cleared when I clicked new. So that's great because it means I'm not typing them all in again, which will save me a lot of effort. But you will need to, if you want to copy this verbatim, A is 0, BX is 50 and BY is 0. So if I go up here, 50 and 0, so B is that point, A is that point. So there's a good chance that C is that point. Let's have a look, shall we? CX 50, 22. CX is 50, CY is 22. CX is, so that's C, D, E, F, G, H, I, J, K, L. That's A. So M is going to be to do with the coils. Let's go and have a butcher's M. M minus 1120. Minus 1120 M. Now I either went that way or that way, but I'm not sure. N minus 120. Minus 1, so M, N, O, P. That's still M. So QRS will be these, but I don't know how they're arranged. Q is 1620. 16, so Q, and then did we go up or right? 2620 is R. Oops, wrong one. So Q, R, S, I'm guessing that's T. And then the bounding box, I'd probably name those differently. Yeah, so we've got bounding box 1, 2, 3, and 4 to make the box. So you actually have all the information you need to do that. There's no need for me to do it again, which will somewhat lessen the length of the video. To do it, you just click and type, double click and type, and then if you need to do loads, it's going to get angry with me if I do that. Call it 80. Press tab and you get a new one up. So you don't have to use the mouse very much. Remove. Cool. So that's in Notebook. Going back to the, you may as well do that first. If you keep coming back to it, it's just frustrating. Just in case you need to look at the diagram one last time, you don't want to go back. That's what it looks like. Take your screenshot now. Good. Back into the object browser then. We start off with points, then we do lines, then we connect up lines, then we do faces, and blah blah blah. So, new entity, basic, point. We will call it A. It will have an X dimension of A and a Y dimension of A, and it is a point. Apply. There, point, see? Right, I got to like L, didn't I? M, S, T. And then there's a bounding box to do as well, so it's 26 letters takes to Z, so there's quite a few points to do. So it is very much tedious. Got to be quite careful about how you label everything. Reasonably fastidious. Oh, you know, bugger. Okay, so that's A and B. Let's see if we can go on plane. Not that plane, not that one. Not that one. Surely it's one of these. What's going on here? Oops. Okay. It's going to be frustrating for it. Once we've actually got some more, it might make it a bit easier for me to see which. What I really want is X along the screen and Y into the screen, and Z upwards. OY, OY plus. I was convinced it was one of these two. Yeah, it is, that one. It's just difficult to tell, there's only 2 points. So that's A, that's B. Yeah, that's A, that's B. So if you were to double click this now, or try and right click it and think about editing it, as far as I'm aware, you cannot. If you need to change where B is, you've got to go back to the notebook and change these two. Or one of them, at least. So if you were to go new entity basic point, click that, call it something sensible as C, and then I type the numbers in here and OK it. If I need to move that point, the only thing I could do is delete it and make a new one and call it C. That's why you want to put all your variables in the notebook. CX, CY, apply. I wish I could tell you now, whoops, what timestamp on the video I would finish this bit, but since I haven't done it, I don't. Just have to sit here. No, click the wrong button. Obviously, if this was a 3D problem, then we'd have Z to do as well. But if it was a 3D problem, we wouldn't do it like this. We'd be using blocks and intersecting the blocks with other things like cylinders and spheres and toruses, whatever, and then filleting the edges to make complex shapes that way, which is quite similar to how you can do it in COMSOL. Alternatively, we could just import a step file. So if I was to zoom out a bit now, there we go. So we have A, B, C, D, E, F, G, H. That's the, what's that one do? Well, that's pan, so you can pan like that. That's zoom to extents, I think. Is it? Not sure. A little experimenting required. I, X, I, Y. Oh no. No. What have we done? Geometry. J. JX, JY. New entity. K. This is actually why the bear looks so angry, because he's had to sit through this already. Okay, so the core's done now. A, B, C, D, E, F, G, H, I, J, K, L. And then we've just done M, which is the first of 4 here for the one part of the coil, in quotes. I say in quotes because there is a coil solver in Elmer, and there's also another, not solver. I did that earlier in the other video as well. I used the word solver and to mean model sometimes, so I shouldn't do that. I should be more careful. There is a coil solver model in Elmer, and there is another model called circuits and dynamics, and we will use those eventually, or we'll use the circuits and dynamics model eventually. So I should be careful not to call it solver, and I should be careful not to call this a coil, because really all it is a rectangular section in which we would impose a current density. It's not a coil, but we all know that this is an inductor and that's a coil. Or if you didn't know that, then you do now. I think this is a bit. I don't know if the countdown exists in other countries. It's a TV show where you get 9 letters, and you're allowed up to 4 vowels, and you have to make the longest word you can out of the random letters that are chosen. And there are numbers games as well, which I am much better at. OP. I like the numbers games. The letters games not so good. It's difficult for bears. P, Q, Q, Y. So we've just done one, and now we're going to do the next 4 are going to be there. There is something actually quite satisfying about seeing the shape appearing. Q, alphabet. I can do the alphabet. Oh yeah. R, S. One more. I think. Yeah, one coil there, one coil there. And that's the inner edge of the thing. Cool. Better save this, hadn't I? We shall save it as. I don't need a new folder for that. Delete. We'll save it as video inductor, because I'm videoing it. The little eye means that we can see them, and when we start making edges or lines, edges, and he slips into console speak then, we'll find these are turned off for us and we only look at the lines. So we've got to do the bounding box, which is going to be the outside region. Oops. I think that's what I called it. I think I did. Two more to do. Last one. Okay. So then we have to start making the lines. So we do new entity, basic, line. You know where this is heading, don't you? AB. Point 1, A. Point 2, B. Apply. So if you missed that, go back and see it, but the point A and point B have disappeared and there's a line instead, which links the two. And the little eye symbol is gone. Seems vaguely ancient Egyptian. So we do this some more. BC, B, C, D, F, G, HI. Kind of wish I'd done an air cored solenoid now. Would have saved a lot of work. Wouldn't be as fun though. Let it begin to IJ. JK. If I knew a Jamiroquai song, I could make a joke now. JK, JK, that's it, yeah, J, K, UNC, line, KL, ooh, Kuala Lumpur, K, L, and where are we going now? L is the last one, isn't it? M is something else, so L, A. Well, hang on, what are we doing? Something's come along there, it's a line. Try again. L, A. So that's the core. So we've got to do the coils, or the coil, and which is not really a coil as we previously said, and the bounding box. So I'm just going to save that because I'll die a bit inside if I lose it. So we'll do the coils now. MN. Repeat. And PM. Should close off this coil by giving it that line there. You can see it in purple. Right, saved. Next one. Basic. Damn you. Basic line. My son is at an age now where I might be at risk of teaching him to swear, so I've got to make sure I don't swear. Very important. MNOPQ. QR. Q. Yeah. Somebody will probably email me now and say there's a very quick way to do this in Python. You've wasted a lot of time. RS. Because you can code in Python down here and tell it to do stuff. RS. New entry. No. ST. T. TQ. And then we'll save it and do the bounding boxes, or the bounding box. So we'll do BB12. BB23. BB34. 341. Okay, so now we have a selection of lines. The points are still there, it's just they're not visible. We can make them visible again. Just turn that one on. You can dump that as a Python script by clicking dump study and saving it. And you can load a Python script and it will essentially, it's like a macro. I think somebody will probably write to me and tell me that's not quite true now. If you have emailed me at some point, especially to tell me I've done something wrong, which I probably have, and I never answered, I'm really sorry, but I am very busy. I do try and answer. It doesn't always happen. Sometimes they slide down my inbox and disappear out of sight off the back of my virtual desk, never to be seen again. So, what do we do now? Now we need some faces. So, entity. We need to, should we group them at this point? Could do, can't we? Let's group them. Groups and mesh groups, which are called by the same menu action, but when you're in mesh here, not in geometry, are the means through which Elmer allows the selection of edges and vertexes and faces and volumes. So if you don't create groups now, you have to go back and create groups later in order that the meshing will be done in such a way that you will have access when you're setting up your problem in Elmer GUI to the edges and vertexes and volumes and so forth that you need. So you can't avoid creating groups. Best thing to do is, if you're in doubt, just group it anyway. And if you don't use it, oh well. So we can do groups of nodes, but I'm pretty sure I won't need them, so we'll do some groups of lines. I don't really think I will need more than one group of lines, and that specific group of lines is the bounding box, because I need to set a boundary there. If I was doing some other sort of 2D problem like, I don't know, a favourite problem sheet from years past was a bar of germanium is heated at one end. What happens to the carrier concentration? But let's just suppose it's a bar of germanium heated at one end, and I had it in 2D, it was just a bar, and I wanted to put a force, a heat flux on one of the edges. I'd need to make sure I had access to that. I don't need to put any magnetic current density on any of these lines. I'm going to put it on this face, but since I haven't made the faces yet, I don't need to make groups for that. So I'm pretty sure I only need to group this outer set of lines, because I do know that I'm going to have to put an infinite boundary on there later to keep all the flux in. Right, so we'll call it bounding box, and the main shape will be, got a feeling I'm going to run into trouble here. If I did that, is it going to get mad at me? I think it is. Yep. Okay. Something's wrong there then. What have I done wrong here? Let us return to that later. Well, I'm fairly certain I have to do it now. To build the faces, build face. So we'll call it bounding box. Objects, you can click several. So I'll click Shift, click, click, click. Come on. Click. Oh, damn you. Click. There we go. And you wanted to create a planar face. Applying close. Okay. So now the lines have gone away. They've all gone greyed out, and we've got a bounding box instead. We'll do the same for the coil. Deselect. Oh no! Pain, anguish, and death. Which ones is that one? That one, that one, and that one, isn't it? Right, there we go. Much easier to do it that way. Build, face, done. No mucking about. Let's do the outer coil, outer, because it's outside of the core. And we have, oops, T through these ones. That will be coiling up. And we need core, which is everything else from A through L. New, build, face, core. Right, let's go back to the edges now, just see how I went wrong. If I select that and go group, create group, it's a group of lines. It's called the bounding box. And the reason I knew I'd wandered off the correct path before is that when you create a group, you have to choose a shape, which is the shape that all the objects you wish to group belong to. So before I wanted to group this line and this line, and this line and this line, but they were independent of each other. They were just lines. They weren't members of a face. Now I want to create a group of lines, but all those lines have to be part of a face. And in this case, the thing they're part of is the bounding box. So what I can do then, when I click that, I can select lines. Click that one. Damn you. I click that one. Right. Get rid of that. What went wrong there is I still had that selected. I've pressed shift, which obviously you can't see. I could do this over here, which would probably make it a lot easier, but old habits. Then I click add, and it tells me that. So it's called the bounding box, and we'll see it appear over here, which I've just pointed at with my finger. I'm very tired. Got a young baby. So what we have is the face called bounding box, which is composed of these lines, and it has a group which is those lines, and we'll need that later. You'll see it'll appear in Elmer. I know what you're thinking. You think, oh, in comp, so I don't have to do anything. I just click them. Yep, that's true. So what else do we need to do? So the coil outer, we've got a face, and that's all we need. We're not going to select any of these lines. We've got a core, we're not going to select any of these lines either. And we've got the other coil, which we're not going to select any lines, or indeed the corners. You could impress it. I don't know what you could impress at a corner. Something. Trying to think of something physical you can. I don't want to say anything wrong. I don't know. You could put the bit where the PD equals 0, you could have equals something else and impress that at a corner or an edge or whatever. Let's just switch off that one so I don't have to look at it. There you are. Is that it? Yeah, it is. Okay, let's save it. So we've got our group of edges and we've got our faces. Let's just make sure we have. If I build a group, and it's a group of faces, and it consists of the main shape is coil outer. It doesn't contain anything. What will it do? It gets angry with me. So you can't create a group of faces with nothing in them. It doesn't matter that that's changed colour. It's just a a curiosity of Salome. Right, so we're good for now. We've got our core, our coiling, our coil outer, and our bounding box, and we've got a selection of the outside edges, which we will need later. Let's say I saved it. You could dump it at this point if you wanted to. I think we are ready to partition. Why do you need to partition it? Well, you need to partition it because at the moment, if you were to try to mesh this, you can mesh that, and you can mesh that, and you can mesh that, and you can mesh that. And none of the meshes will actually meet on the edges of these objects, where the lines are. And that means you don't have one mesh, and then you might think, oh, okay, well, I'll combine the 4 meshes. No. If you try and do that, you'll end up looking like him. Very, very angry. So we need to do operations, partition. Now, I'm not going to make any jokes about partition. Although the English have partitioned many countries, and it has never ended well. Soon Scotland may be partitioned, but from England. That may not end well. And we partitioned ourselves from Europe. That has not necessarily gone that well. It's too sad. But in partitioning these 4 faces, we will bring them together. Maybe there's a lesson there. Or maybe I'll just stick to the finite element. Right, name. Party. Choose something I can actually spell. Final problem. Objects. We will select those 4 objects. You don't have to use any tool. The resulting type is a face because it's a 2D thing that we want. That's it. Apply and close. So then we have our final problem. And all the others have been switched off. Even though we can still see them, if I do that, we only have the bounding box selection, which is still on because of that. So this is the thing we're going to end up meshing. It's composed of all these different bits. Oops, wrong one. So they're still there and they exist, but we've got one that is them all. So it'll save that. Right. Now, presuming I haven't forgotten anything or screwed up, we can go and mesh this. I'm going to go and open the other version, which I already simulated, and just make sure that I didn't miss anything, because if I've missed something now, it's committed to the video forever. And people email me and say, it doesn't work. And they'll be right, which would be very sad for me. So this is the one that I already did some time ago. Let's go down the image. It's already got the mesh in it as well. So I had a coil inner. Oh, I did the perimeters of that lot as well. I didn't need to, pretty sure. Bounding box perimeter. Can you see some of this stuff? Oops, wrong one. That's it. So that's my bounding box perimeter. That's my partition geometry. It is composed of all faces. Oh, I did face groups. I did face groups by the looks of it. Okay. So I have missed something. No good. Right then, what are you? You're a group. You're a group of faces. Cool. So I've got to make sure I can do that. Back you go. Usually it wouldn't. It wouldn't matter if I missed something now, I fire up Elmer, realise I didn't have what I needed and go back and correct it. Or I'd start meshing it, realise that it wasn't meshing the way I wanted to and go back and correct the geometry. But because this is going to be a video on its own, I'll only know I've done it wrong when I'm in another video and I'll have to go back and re-record this video. I don't have time for that. So we need to do some groups apparently. So this is going to be called Coiling. It's a group of faces, group of one face. The final, the main shape is final problem. I'm going to select a face which is Coiling, which is that one. Add it. If I didn't do this, if I carried on with my thinking I was finished when I wasn't, when I got into Elmer, I'd want to put a body force on this, and it wouldn't let me select it. I'd run my mouse over it and it would all be selected or none be selected. I wouldn't be able to go and select this bit separately from the bits around it. So it's very important that I did this step. So we'll apply and close that. Turn that one back on. Group, create group, coil, outer. Main shape is still final problem. It's a face. It's that face. That face. 55. Yeah. We have to select the core because we need to put materials on these regions as well. We need to tell it that this is a ferrite. We need to tell it that these are copper and that the other stuff's air. And we also need to make sure that the bounding box is grouped as well in the what I'm calling the final problem, which is the partitioned set of the faces that we already created before. So if you were left to your own devices to find this out by trial and error, it would take quite a long time of trawling the internet looking for the help you need. There are some good YouTube videos by someone whose name I've forgotten, but I'll put it in the video description, and there is also a link I will include to a PDF that you use to be able to get from the Elmer wiki, but the Elmer wiki is at the time of recording offline, but you can get the PDF through, it's been posted somewhere else, so I'll put a link to that as well, which is quite useful because it demonstrates some elements of what we've done here. So we need to do the air. So that one, then our face, that one. Right, so it's actually not selected that or that or that, it's selected everything that surrounds, including this bit in here and that thin little tiny little bit up there and that thin little tiny bit up there. If you're wondering, could I not have run this right up to that and made them, this is a Y is 0 on this line, sorry, pardon me, the X is 0 on this line, oh dear, long day. Could I not have run that on there and it would have been fine? Did I need to leave this gap? I didn't need to leave the gap. The reason I've done it is so that when we mesh it, we can watch the mesher mesh up really small and squish itself through that gap, which is fun. And the problem solves really quickly anyway, so it doesn't matter. It's not meant to be a tour de force in mesh refinement or in solver refinement or anything. It's to get the overall workflow and to demonstrate it. But I thought it would be fun to make it look a bit odd. So that's the air, and you can see that this is blank now if I was to move it. The way I'm doing the rotation is I'm pressing Control and then I'm clicking the right mouse button, and then I'm moving the mouse. So you can see as a whole there. I could look through it maybe. Can I look through it? See if I can see that. Yeah, you can look through it, so you can see the axis. Nope. Try again. Yep. So that's the air. So we've got the coil in and the coil out of the air. So we've got to do group, create. This is going to be a face group. This is going to be called core. Now the main shape is the file problem. Oops. And then I will choose that bit, add it, apply close. Fine. Done. Alright then. And we will do one more just in case. Create group, whoops. Please select a group to edit. No. Create group. Group, create. It will be called the bounding box. It's a group of edges. Bit of a nuisance to have the axis switched on. We could turn it off probably and go all the way up to the top. Nope. Oh well, somewhere oh there it is. You turn off the axis. So its final problem, they're groups of lines, and we select that one, that one, that one, that one. Pretty sure you can do that from the side panel as well. Add. Bounding box. Fine. Okay, good. So we've got our geometry. Whoops. We've got our geometry. Come on. There we go. Geometry groups in our final problem. Insufficient disk space. That would be interesting. Is it because I've got it open somewhere else by any chance? Okay. We shall solve that in the classic way. Really? That does not bode well. 257 gigabytes free. Should be okay. Maybe it's this directory it's unhappy with. I'll put it on my desktop. Okay, so this is a crisis. Let's dump the study, or try to dump the study. Let's just see if it's actually there. Well, maybe it's a Python script. Not seeing it. Is that where I put it? Video.py. Desktop. Ah, I put it on desktop. Idiot. Okay. Don't really want it there. We'll drop it back into here. Except you won't let me paste it because this is Java in disguise. We'll do it again then. With a small v. Cool, is there. Right, so the plan now is, I wish I could save this. It's such a frustration. Yes. Well, I'd love to, but you won't let me. Yep. Bye bye. Go away now. Right. Well, that was unexpected. Let's go find it. Now we'll see if the load script works. Cool, that's okay then. I don't know why I didn't want to save that. It was a bit weird. I think it's probably because I had opened a different one, didn't I? I don't know. We survived it, let's put it that way. Right, let's just save over that. Yeah, works that time. Weird. Good. So I think we're ready for meshing now. I think. Let's hope, eh? How are we doing for time on this one? We have been going for 50 minutes. I think that's probably enough. Nobody wants to sit for more than an hour watching somebody do something like this. Next thing we would do is mesh. And what I'm going to do is I'm going to just quickly make sure it meshes. And the reason I'm going to do that is so that I know if I've missed anything in the video. So I'm not going to talk about this, I'm just going to do it just to make sure it's okay. It's a bloody thing. Okay, so it did mesh as one whole thing. I'm not very happy with the mesh, but that doesn't matter. So what we'll do is I will go through that in another video. So I'll just delete that so that you don't see it. We'll stop here. Cool. Well, I should like to say I hope you enjoyed that, but it was fairly torturous, wasn't it? He doesn't answer. I shall see you in the next video. Thank you very much.